Okay, this is an important paper. It talks about how droughts are becoming more towards flash droughts. Basically, I think you get the idea. Flash drought is something that evolves very rapidly. When we think about extreme events, we usually think about floods, heavy rains, cyclones, etc. Whereas you think of droughts as evolving slowly, but if they begin to evolve very fast, then they have also a lot of other consequences. The consequences can be reversible, they can be very difficult to predict, and impacts can be, quite severe. So, keeping all that in mind, I'm recording this short podcast. It's a nice paper. As usual, I'm going to be brief. It's called A Global Transition to Flash Droughts Under Climate Change. It's a science paper by these authors here. Flash droughts have occurred frequently worldwide with a rapid onset that challenges drought monitoring and forecasting capabilities. However, there is no consensus on whether flash droughts have become the new normal, because slow droughts may also increase. So you may have kind of slowly evolving droughts that are also happening, whereas some droughts are becoming flash droughts. In this study, we show that drought intensification rates have sped up over subseasonal timescales, and that there has been a transition towards more flash droughts over 75% of the global regions identified by the Intergovernmental Panel on Climate Change (IPCC) Special Report on Extreme Events during the past 64 years. The paper is from end of 2023, so I'm recording about 8 months later, but anyway, it's still very relevant. The transition is associated with amplified anomalies of evapotranspiration and precipitation deficit caused by anthropogenic climate change. So you have to be careful about these words, because attribution of rainfall or any signal anomaly can be tricky. In the future, the transition is projected to expand to most land areas with larger increases under higher emission scenarios. These findings underscore the urgency for adapting to faster onset droughts in a warmer future. So let's leave the future projections alone, because forecasting rainfall, projecting rainfall, even getting the signals out of data is always tricky, because rainfall is very small scale as opposed to other variables like temperature, which have intrinsically larger scales. I like to put these caveats, because sometimes we underestimate the uncertainty in saying, let's say, what will happen to flash droughts in 2100, or what can you even do about them. So forecasting now becomes the most important thing, and we shouldn't lose that focus. So global distribution of flash and slow droughts. I'll just read bits and pieces of the text and hardly the whole paper. On the basis of estimates of soil moisture from these three global reanalysis from 1951, from three global reanalysis from, not these three, from three global reanalysis from 1951 to 2014, subseasonal drought events are identified as pentad mean soil moisture declines from above the 40th percentile to below the 20th percentile, and then increase to above the 20th percentile again, so that you have a drop and increase and happening at intraseasonal time scale. So you flash drought because it recovers. Otherwise, if it persists, it becomes a slow drought, right? The rate of change matters as well. The minimum duration for subseasonal drought is 20 days to exclude dry spells that are too short to cause substantial impacts. We then divided the subseasonal droughts into flash and slow droughts depending on the rate of the reduction in soil moisture during the onset stage. We used the ratio of flash drought events to the total number of subseasonal drought events and the subseasonal drought onset speed. So you can follow up on the methodology section. To quantify the transition to flash droughts by determining whether there are significant trends in these two indices, they use this rate. Flash droughts tend to occur more often than slow droughts over humid regions with lower aridity. Okay, so flash droughts are actually occurring in wetter places, more humid places, where flash drought frequency is 2 to 3 times greater than other regions. By contrast, slow drought occurrence has smaller spatial variability. Flash droughts usually last for 30 to 45 days, whereas slow droughts usually last for 40 to 60 days. So it's a slight shift in the time scales. Uncertainty across the three reanalysis is slower over the most humid and semi-humid regions, but high over arid regions. So uncertainty is higher where the signal is stronger in terms of humidity. Remember, soil moisture is also very small scale variable, and reanalysis can have all sorts of issues, and reanalysis themselves have an intrinsic spatial scale which is typically now at 25 kilometers. What about detection and attribution of changes in global droughts? Given the global land evapotranspiration is increasing in a warming climate, that's very intuitive. If you increase atmospheric temperature, it gets thirstier, demands more moisture, so evapotranspiration goes up. It was hypothesized based on this that drought onset may speed up globally. In this study, we provide robust estimation that there are upward trends in the global mean flash drought ratio. So with very high confidence of 99% confidence level, the subseasonal drought onset speed from 1951 to 2014 is also upward, trending upward, which means that subseasonal droughts have developed faster and shifted from slow to flash droughts at global scale. This is like extreme rainfall events. If heavy rainfall events have increased, then they have come at the cost of moderate rainfall events which have decreased. Okay, to assess whether the global trends are sensitive to the definition of flash droughts, we increased and decreased the soil moisture thresholds for drought starting and ending points, as well as drought onset speed, and found that the upward global trends remain significant with 99% confidence level. Okay, I'll just show some figures and then we'll read the discussion a little bit. Observed ratio of flash droughts to subseasonal droughts, so that you can see if there is a shift. Observed subseasonal drought onset speed. So these are percentage pentads. I chopped off that here, but spatial distributions of the flash drought ratio and the onset speed of subseasonal droughts is the ratio in percentages of flash drought events to the sum of flash and slow drought events, so subseasonal drought events. The mean onset speed in terms of percentage per pentad. So this is percentage and this is percentage per pentad. How quickly they're evolving for both flash and slow droughts. All statistics are based on the average results from three reanalysis that we already mentioned: ERA 5, GL-V version 2.0 / NOVA, and GL- version 2.0 / catchment. They are all global reanalysis data during the growing season of 1951 to 2014. So April to September for the northern hemisphere and October to March for the southern hemisphere. So you match it this way so that you can show them together, but you have to remember different seasons, but growing seasons in each hemisphere. So you can see there are some hot spots in terms of the onset speeds. The Amazon region here, Sahel and Central Africa, core monsoon zone of India, and then you have these parts of China and maybe Nepal, Thailand, Myanmar, and then you have here Southeast Asian countries, New Guinea, and this is Malaysia. So attribution for changes in global mean flash drought ratio and onset speed of subseasonal droughts. This is observed and simulated anomalies of the ratio of flash drought events to subseasonal drought events averaged over the globe from 1951 to 2014. So this is the ratio anomaly from 1951 to 2014, again for growing season. You have all and observed and natural forcing. So you are trying to basically do some sort of an attribution where you use greenhouse gas forcing as well as solar, volcanoes, aerosols, and so on, and you remove greenhouse gases to see whether there is contribution from anthropogenic forcing, or if it is natural. Okay, so the thick lines are 10-year running means, display 5 to 95% range of all and net ensemble simulations, and so on. So you can follow up the details. So here is the onset speed anomaly for the same things, and you can see observations have higher frequencies, whereas the climate models tend to produce smoother, but we know that they are better at the trends given the anthropogenic greenhouse gas forcing as opposed to interannual variability, because they are not forecast models, they are simulating, and they are good at simulating the trends given the forcing. So scaling factors, attribution trends from anthropogenic, natural, observed, anthropogenic, natural. So you are trying to say that there is in fact a detectable contribution from anthropogenic forcing to the transition from slow droughts to flash droughts. Okay, so this is historical trend in flash drought ratio, and here is the scale. So all the yellow to red lines are increasing trends. So this is the future trend in flash droughts, basically saying everywhere it's going to increase. But as I said, I'm a bit skeptical about projections, so let's leave it there. Especially far out into the future where scenario uncertainties dominate. The first 2 decades it could be model uncertainties, but I like the historical analysis where you can see that there are regions where there have been reductions in flash droughts. You can follow up on what the details are, but here there is a warming hole where the warming is somehow not occurring, and I think there are papers on that you can follow up. Our hotspots here are the dry regions, semi-arid regions. So the moist regions here have seen a decrease, and Europe is a hotspot here. India has got a slight increase, and so on and so forth. And here you have drought onset. So again, the smorgasbord of numbers, but you can see that even though there is historical trend is negative in the flash drought ratio, the rate is increasing. So onset speed is increasing, which means they may flip over to increasing percentage of flash droughts in the coming years or decades. And these are red in both the ratio and the speed. Okay, so just keep that in mind. Again, I'm ignoring the future trends. Implications for climate adaptation from these: the transition towards more frequent flash droughts presents challenges for unraveling the anthropogenic influence on compound extremes, where you have multiple things. You may have a heat wave, a drought, and water resource problems, and so on and so forth, crop losses, food security issues. This will broaden our understanding of the drought impacts in terms of understanding the anthropogenic influence. So this is a challenge across time scales, and improving drought prediction capability for timely early warnings are also big challenges that are coming already with these flash drought increases or transition towards flash droughts. The increasing drought onset speed primarily comes from intensifying rainfall deficit and increasing evapotranspiration caused by anthropogenic climate change. So the warming is fairly clear, global mean at least, but there are patterns you have to be very careful about. India shows in large parts a cooling trend, but India is tricky because if you look at annual mean, it can be misleading because seasonal transitions are more important, or which season warming is more important. Okay, so this anthropogenic climate change drives the soil quickly and creates ideal conditions for heat waves. Because the co-occurrence of heat waves and droughts is increasing globally, according to the latest IPCC 6th assessment report, the anthropogenic enhanced transition to flash drought suggests the need to understand flash drought heat wave interactions both locally and remotely under climate change. So slight transition towards commenting on compound events that will be associated with flash droughts. Anthropogenic climate change is driving the transition to flash droughts, which has a wide range of implications for our understanding of climate change and its impacts, as well as how we can adapt to these changes. Improved understanding is needed for the adaptive capacity of natural ecosystems and human-managed environments that may be my throat suddenly dried up, that may be more susceptible to flash droughts and associated compound extreme events. Early warning of flash drought onset on time scales of a few weeks can be hugely beneficial for mitigating their impacts and managing the risk of this new normal. These words, new normal, are always kind of tricky, so you have to be careful nonetheless. But what can you do with prediction of a flash drought? Can you go and protect the crops by irrigating them, monitoring crop stresses better, prepare for heat waves, and so on and so forth? So lots of useful things in terms of mitigating the impacts can come out of good, reliable, long lead early warnings. So let's leave this here. Main message: the droughts do seem to be transitioning to flash droughts across the globes, with some hotspots like Europe and Eurasia spreading into Siberia and so on. Okay.